Hello friends, welcome to my YouTube channel Maths DNA to infinity. Before we begin, let me ask you a question. What is the one word which can be used to complete all these words? Comment your answer below in the comment box. This is my 10th lecture on real analysis and the topic is types of sequences. In this lecture, we will discuss about convergent sequence, divergent sequence, oscillatory sequence, finitely oscillatory sequence, infinitely oscillatory sequence, and some examples from competitive exams. Let us begin. What do we mean by a convergent sequence? A sequence n is said to be convergent if and only if limit superior is equals to the limit inferior and they exist finitely. That is, limit superior of an is equals to limit inferior of an is equals to L, where L belongs to R. For example, let an is equals to 2020 for all n belongs to n, then an is convergent as limit superior of an is equals to limit inferior of an is equals to 2020, a constant sequence. Then what are divergent sequence? A sequence n is said to be divergent if limit superior of an is equals to limit inferior of an is equals to plus infinity or limit superior of an is equals to limit inferior of an is equals to minus infinity. For example, an is equals to n or an is equals to minus n. We need to note it down that divergent sequence is unbounded from one side. Then we have oscillatory sequence. A sequence n is said to be oscillatory sequence if limit superior is not equals to limit inferior. We have finitely oscillatory sequences then, which says that a sequence n is said to be oscillate finitely if both limit superior and limit inferior of n exist finitely and limit superior is not equals to limit inferior. For example, n is equals to minus 1 raised to n. Here the terms are minus 1, 1, minus 1, 1 and so on. We can clearly see that limit superior is equals to 1 and limit inferior is equals to minus 1. They both are existing finitely but they are not equal. So the sequence is finitely oscillatory sequence. Then we have infinitely oscillatory sequence. A sequence n is said to be oscillate infinitely if both limit superior and limit inferior exist infinitely and limit superior is not equals to limit inferior. For example, n is equals to minus 1 raised to n into n. Here limit superior of n is equals to plus infinity and limit inferior of n is equals to minus infinity. They both exist infinitely and they are not equal. So the sequence is infinitely oscillatory sequence. Let us solve some examples from competitive exam. Example 1. Limit n tends to infinity 1 minus 1 by n square raised to n is equals to. The options are A 1, B e raised to minus 1 by 2, C e raised to minus 2 and D e raised to minus 1. This question was asked in CSIR-NET June 2016 Part B. Let us solve the question. Solution. It is given that limit n tends to infinity 1 minus 1 upon n square raised to n, which is equals to limit n tends to infinity 1 plus 1 by n into 1 minus 1 by n whole raised to n, which is equals to limit n tends to infinity. The power n comes inside the bracket, which gives us 1 plus 1 by n raised to n into 1 minus 1 by n raised to n. And we know the limits of these both the terms. The first one is e and the second one is e raised to minus 1. Therefore, e into e raised to minus 1, which is equals to 1. Therefore, the correct answer is option A. Now example 2. For AB belongs to n, consider the sequence dn is equals to nCA upon nCB for n greater than a and b. Then which of the following statements are true as n tends to infinity? The options are dn converges for all the values of a and b, Option B, Dn converges if A is less than B. Option C, Dn converges if A is equals to B. And option D, Dn converges if A is greater than B. This question was asked in CSIR-NET June 2017 Part C. Let us solve the question. Solution. It is given that Dn is equals to Nca upon Ncb, which is equals to n factorial upon n minus a factorial into a factorial into n minus b factorial into b factorial upon n factorial, which is equals to n minus b factorial into b factorial upon n minus a factorial into a factorial. The n factorial gets cancelled out. Now for a less than b. We know that if a is less than b, then minus a is greater than minus b, which implies n minus a is greater than n minus b. Using this equation, we get Dn is equals to n minus b factorial into b factorial upon n minus a factorial into a factorial equals to n minus b factorial into b factorial divided by n minus a into n minus a minus 1 and so on up to n minus b. As we know, n minus a is greater than n minus b. Now here n minus b gets cancelled out and we get Dn tends to 0 as n tends to infinity, as in denominator there are terms of n. Therefore option B is true. Now to b, a is equals to b. We get Dn is equals to n minus a factorial into a factorial upon n minus a factorial into a factorial, which is equals to 1, a constant sequence. Therefore Dn tends to 1 as n tends to infinity. So option C is also true. Now for a greater than b. Now let a is equals to 2 and b is equals to 1. Then we get Dn is equals to n minus 1 factorial into 1 factorial upon n minus 2 factorial into 2 factorial. And we know that n minus 1 into n minus 2 factorial splitting the numerator divided by n minus 2 factorial into 2 factorial, which is equals to n minus 1 upon 2 factorial. The n minus 2 factorial gets cancelled out. And Dn tends to infinity as n tends to infinity, as the numerator has the term of n. So option D is false. Therefore A and D is false and C is true. So the correct answers are option B and C. Thank you, and get the best material for preparation by just one click. The link is given below in the description. Also check out other 30+ videos on my channel.